Hello, everyone. So today we're going to talk about another SQL injection. It's called Boolean-Based Blind SQL. Now, the most important two terms in here is first, the Boolean part, and second is blind. Let me go ahead and explain with simple terms. Boolean is, as you all know, is actually a statement that is either going to be true or false. It has two values. It's either going to be true or false. Now, SQL as a structural language actually understands Boolean statement. You can actually add at the end of a SQL query, you can add a Boolean statement, and the SQL query will return a value based on what is going to be the output of the Boolean statement. If the Boolean statement is true, it's going to return the SQL value, and if it's false, it's not going to return anything. So with that being said, let me go ahead and demonstrate right away what that means. This would be a lot easier if we see it in practical terms. So I'm gonna go ahead and open up obviously one of our application, PinewoodStore. I'm gonna go to the suppliers and log in. All right, so I'm gonna go to orders, and I know there is actually an order number 10, and I would look up the order details. Now, those order details pull up this information. Uh, Now let's go ahead and try to see how this relates to our discussion on Boolean-based blind SQLi. I'm going to open up Burp, and I'm going to go to proxy, open up the browser. Log in. All right, let's start looking at the traffic. First thing, I'm going to go ahead and clear everything out so we can see exactly what we're going to be targeting. I'm going to go to orders. I'm going to put the same thing, and all right, just pulling up this. So let's go back, and this is the order details request. I'm gonna send it to a repeater. Like always, if we made some kind of mistake, we can refer back to the original request. So I usually like to kind of send it multiple times. That way I don't have to go back to the proxy and send it again. Let me send another more. So this is basically a GET request, and it uses a parameter called order ID. When order ID is 10, it's going to give you the details of all the orders, order ID 10. Now, what does this entail as far as our discussion on Boolean-based blind SQLi? Now, the most important terms, the two terms to pay attention to. The first one is Boolean. Like I said, as you can see here, order ID is 10. SQL recognizes what's called a Boolean statement. And now, if this is vulnerable to Boolean-based blind SQLi, and before I go on with the exploitation, how it is carried out, I want to explain what the term blind means. So as an attacker, attackers don't actually see what the database is running in the back end. The reason why I'm able to see everything is because I'm actually on the application, and I'm working on the application. So as an attacker, they're not able to see this, but they can still test and see if the application is vulnerable. And even without knowing if it's a SQL database or not, they can do a couple of tests. So let's go ahead and try to understand what the term Boolean means. So as you can see here, I have this order ID 10. Now, like I referred to it earlier on, if I were to add a Boolean statement next to it using an end, let me go ahead and close it. And we'll use our regular expression 1 is equals to 1 to refer to a Boolean statement that is true. So I'll start with that. Now, I'm going to go ahead, and I have explained it multiple times. I'm going to go ahead, the last single quote, I'm going to leave it out. Is because the SQL statement on the back end adds its own single quote. And if I actually close the single quote, well, it's missing one here. If I actually close this single quote on the right hand side of one, it would actually cause a SQL error because it's going to be two single quotes in the end of the SQL statement. And now, as an attacker, you might not know this, but you can guess by actually trying different payloads, right? If I'm an attacker, I'm actually the first thing, obviously, before I send it. And we've talked about this before as well. If you have a request and the URL has any characters, like special characters, single quotation marks, double quotation marks, or any special characters, or space, and you send it just like this, it will just return 400 bad requests. So what you need to do is actually, you need to URL encode it. So it would actually not get that error message. And I'm also going to show you that I'm going to go ahead and send it, and it will return 400 bad requests, as you can see here. So that's the reason why we need to URL encode it. I'm going to go ahead and select it. Right click, convert selection, URL encode key characters. So as soon as you actually URL encode on the right hand side, you would be able to see, if you select it on the inspector, it would show you what is actually being encoded. So let's say if I want to manipulate something, I can change it here and apply change, and it would actually apply the change, and I can start testing again. So now, if I were to send this, it's not going to have, first off, the single code. Why it is actually required we take it off. So I'm going to go show you that. I'm going to add it, apply change, and I'm going to send it now, and this is going to show you, as a matter of fact, let me show you the back end. So, I mean, we're just trying to understand. As an attacker, you won't be able to see this, but just to understand what's going on in the back end. I'm going to clear this. I'm going to go ahead and send it. Now, as you can see here, actually it does have SQL errors. This is another one I talked about earlier on. If you need to actually manage your queries so it doesn't return any error message that will reveal information to the attacker. But in this case, we can use it to understand this vulnerability or what is going on. As you can see here, the SQL statement, the second SQL statement, or the Boolean statement in this case, does add an additional single quote. That's the reason why it does have that SQL error. And if I look in here too, it would actually show you this is actually adding it. So let's go ahead and clear it, and I'm gonna go ahead and remove it. And if I remove it, and I'm gonna show you, it's actually it's not gonna have any SQL errors anyway. So, and as you can see here, no SQL errors, and also return the data. So this is actually what I was referring to. I added a Boolean statement, which is 1 is equals to 1, which is true. And since it's actually using end, for this query to run and return a value, it always has to have a Boolean statement. If you're going to add a Boolean statement next to end, it needs to have a Boolean statement that is true. Now, let me go ahead and test it with another one just to show you that's the case. I'm going to change it to 2, apply the change, and you will see it would not return the data. It just say total 0. So, as you can see here. So, this is actually, it is vulnerable to Boolean-based blind SQL. Now, how attackers can use this? Is basically attackers can use this to predict values within the databases, because they can add a statement on the right-hand side that would run another query to determine if it's true or false. And within this context is actually we're going to use it to test out to see, let's say we guessed as an attacker there is an admin account. We want to guess the password. In that case, what we can do, we can replace this statement on the right-hand side with another statement that will run a Boolean query to see if the password, the first character of the password for a certain account is actually starts with a certain letter. Let me go back and explain what I mean by that. All right, so let me show you a simple SQL Boolean statement. So this Boolean statement is basically a SQL query. It will do select and use substring, and basically it's going to look at the password field in the suppliers table, and it's going to look at the first, starting from the first character, the first character after the first letter, and it's basically saying the first character of the password and that field. Where are we looking at? From the suppliers table. And which account? Where username is equals to admin. Basically saying, the statement is saying, I want you to select the first character of the account of the password for the account with username admin from the suppliers table. After you select that, compare it with this character I have on the right hand side. So what this is doing is actually is gonna, the result of this is gonna be a Boolean statement. Now, if the first letter of the password for the admin account is actually starts with A, then it will return a true statement. So instead of 1 is equals to 1, we can use this. So that way an attacker can predict the password of a certain account. And it would take some time, but if it is vulnerable, what you can do, you can also automate it, right? It's just a request. You can stagger it. You could use Python to run or to send a repetitive requests by just changing the letters. This is actually very easy to accomplish. But that's the whole concept of it. And I'm gonna go ahead and show you also the back end for the suppliers so we can understand the vulnerability better. All right, so if I were to run this query, as you can see, there is actually an admin account, but the first letter starts with T. Just to show you the vulnerability and you understand. Obviously, this is a blind SQL lie, so an attacker would not have this information, but they would guess it. The first thing they would do is actually test that, right? They're going to use the same thing that we did. They're going to add a true statement on the right-hand side using end, and they're going to add a false statement. And if it returns a value when it's true, then it's actually vulnerable to what's called Boolean-Based Blind SQL lie. Then it can construct the Boolean statement to exploit the vulnerability. That's basically it. The next part of it is just automating it using some kind of Python script to send a request repetitive times, because you don't want to be sitting here trying different letters, right? It's not realistic in today's world. Of course, if it's a password that's not that long, ideally it's doable, but we want to, from an attacker's point of view, it's just, you got to look at it this way. They don't have a whole lot of time to do it because, first thing, obviously, there's going to be alert system that is just going to be detecting this kind of attacks. So let's go ahead and take a look. And like I talked about, I'm going to go ahead and let me select it again. The statement after 1, I'm going to go ahead and replace it with mine, and which is going to be this statement. So if I were to add this statement, let me remind you one thing. Never forget that the single quote. A lot of SQL queries would add that. So if you're testing something and with first trial it fails, it's always good to try with single quote off, single quote on, removing the location of the single quote. It actually helps. So that's where automated tools come in. But it's best to understand what goes on behind so you can actually craft a better payload. So we copy it. And I'm going to replace this statement with mine. Now I'm going to go ahead and take this one out because we already talked about that. I don't have to explain because that's dangling single quotation mark. Apply. Let me go ahead and send it. Now, let me remind you something. If you look at this, the admin account, the first letter is T. But what I'm testing right now is A. Just to show you how the attack will go through. So if I were to send this, it would say something like this. You see, this is not a SQL error, but it didn't return anything. What that tells the attacker is the first letter is not A. But if I were to put something else, like let's say we know it is T, So if I were to put T and apply change, send it, is actually returning the data. So it is telling the attacker that it actually the first password, the first thing, the admin username exists, and also the first letter is T. So the next part of the process from the perspective of the attacker is actually automating this using Python script, which is not going to be a sophisticated task, honestly. It's just going to be a small script. It just sends a request multiple times. You could stagger it. It does have, Python has a lot of libraries that you can use to stagger it. So if you, in this case, if you have some kind of WAF that would try to detect this kind of attack, here's the thing. Most WAFs nowadays, to be honest, like we just don't understand it, but most WAFs will actually, if you URL encode it, they still decode it and actually check the contents of this. And if it is something, if it has special characters like this, and or something where a normal SQL query would not send an and or single quotes in a URL parameters. So most of the time this would be detected by WAF. But just to understand what the vulnerabilities, this is how they exploit it. If an attacker, most of the time, if they were to exploit this, they can't be in front, the application can't be in front of a WAF. Most WAFs would detect this. As a matter of fact, I have set up another lab. I don't know if most of you are aware, there is a free WAF that you can try. It's called Mod Security. What I did is I actually created Mod Security like as a deployment. Docker is already set up. So the next lab is going to be that. I'm going to go ahead and start it. And I'm going to show you how the attack will go through when you actually have a WAF in front of your application. And you would see most of these attacks would actually be caught, because you got to think of it this way. Mod Security is an open source WAF. It doesn't even have a lot of rules, but commercial WAFs would have a lot of rules to detect even sophisticated attacks known out there. So even with a simple setup like that, you can actually protect your application. But we're going to take a look at that. And from an attacker's point of view, if you want to understand it, it's better if you try to test something, especially if you do a lot of bug bounty programs. They're not going to take down the firewall for you. If you're going to find something, you're going to have to find a way to bypass a WAF too. So that's the reason why I set it up. We're going to take a look at that in another lab. But yeah,